Hello everyone, this is Professor Evans and this is a demonstration of Lab 9. This is the BCD counter. So switch 2 is going to control whether we can see the counter at all. So it just enables and disables the hex displays to be on or off. Switch 1 will enable it to count approximately 1 digit every second. This is a BCD counter, which means each digit will count from 0 to 9. And then switch 0 will be your clear. And then it'll begin counting again once you deactivate the clear. Notice that I can take switch 2 low and disable the hex output, but it's still counting. So even though I can't see it, it should still be counting because switch 1, which is my count enable, is high. So that's the first part, the BCD counter. And now here's part C, which is the real-time clock. My switch 9 is going to be the enable for the clock to begin counting. Now for testing purposes, you can speed up your display. So ideally this should display 1 new digit every second, but to test it and make sure that it goes all the way through all of the digits properly, you can speed up your algorithm. So instead of counting approximately 50 million clock cycles, count 25 million or 12.5 million, and that way this will go faster. And you can verify that it works without sitting here and actually watching it for an hour. But this is the real-time clock. So you can imagine right now that these are the seconds. And then these two hex displays over here will display your minutes. So it should count all the way up to 59 minutes and 59 seconds before rolling back over to 0 all the way across the board. But I'll just show you the first minute here. So now we're at 1 minute and we're continuing to count. So notice that this display has to go from 0 to 9. This display has to go from 0 to 5. So think about how you would have to implement your algorithms in order to control the display, depending on whether it is the tens digit or the ones digit, and the idea that you're implementing time. So the tens digit in time only goes up to 5. And that's part C.